everyone, so welcome again to my vlog. So for today's video, I am going to discuss about the derivative. So the derivative is we notice this one, the limit this figure is called the derivative of f at a. So we write f prime equal limit of f quantity x plus h minus f of x over h approaches to 0. That derivative of f with respect to x is, there are many ways to write the derivative of y equal f of x. F prime, that's what we call f prime, if you notice that one. Or the derivative of f with respect to x. This one, y prime. This one, dy dx, or the derivative of y with respect to x. df dx, this one called df dx, or the derivative of f with respect to x. This one is called ddx of of x, also called the derivative of f of x. So note for those who didn't know, so this one, d does not mean dx, does not mean d times x. That's wrong. Also this one does not mean d times y. And also this does not mean dy divide dx. If you noticed last slide, that's not mean dy divide dx. So except when it is convenient to think of it as division, maybe f, also this one, df dx does not mean d divide dx. So except when it is convenient to think of it as division, but if not, so that's called df dx. So this one, dd f of f, so does not mean d divide or d times f of x, except it when it is convenient to think, diba? So this one, the derivative of slope of the original function. So if y equal f of x, that's the original slope of function. If you notice that kind of that represent to us, no? So that is also called, the derivative is defined at the endpoints of function on a closed interval. That's what we call the endpoints of function. That is y equal x squared minus 3, or we are going to distribute that one, y prime equal limit quantity x plus h squared minus 3 negative quantity x squared minus 3 over h approaches to 0. So y prime limit of x squared plus 2xh plus h squared minus x, so we'll cancel out x squared and h. So we have y prime equal limit 2x plus h approaches to 0. We're going to cancel out, becomes 0. So we have y prime equal 2x. So our graph will be like this. So, and also a function is differentiable if it has a different derivative where everywhere in its domain. It must be continuous and smooth function. Closed interval must have one-sided interval defined at the end point. So that's it. If you really listen to me, you have a deeper you are learning, and I know that you are good in listening so that you are have a good